The broadcast is now starting. All attendees are in listen-only mode.
Okay, hello everyone. Welcome to today's Pedestrian and Bicycle Information Center webinar. My name is Dan Jolene. I'm going to be facilitating the webinar here today. And we're all here today to talk about how we measure the true safety effects of countermeasures that we install for bicyclists and pedestrians. We're going to be diving into methods for evaluation and really talk a lot about crash modification factors, how we use them, how they're developed, and what information we can be collecting to really increase the number of bicycle and pedestrian evaluations that are going on, and as well as crash modification factors. So we have a really exciting topic. It's one that's near and dear to our hearts here at the Highway Safety Research Center, and I'm joined by a number of my colleagues who will be talking through a lot of this material with us and sharing some of their thoughts on safety evaluation. So I want to introduce them each briefly here. First, we have Daniel Carter, who is a senior engineering research associate here at HSRC. He's been involved in numerous projects over the years to evaluate safety improvements and develop crash modification factors. He manages the Federal Highway Administration's Crash Modification Factors Clearinghouse, which he'll be talking about a little bit later in the webinar. Raghavan Srinivasan is also here. He's a senior transportation research engineer here at HSRC. He's got more than 20 years of experience performing research and safety evaluation, focusing on a wide range of countermeasures. His research includes traffic engineering and safety, human factors, and the application of statistical and econometric methods. We're also joined by Krista Nordback. She is a senior research associate here at HSRC, specializing in pedestrian and bicyclist mobility and safety. Her research covers many areas that includes a strong focus on the development of estimating bicyclist volumes and developing safety performance functions for bicyclists. She's working with agencies around the country on improving bicycle and pedestrian volume data collection through count programs. We also have a special guest joining us today, Charlie Zagier. Many of you may know, has done a number of pedestrian and bicycle research studies in his day. He's going to be sitting in and contributing to our panel as we move along. We have a lot of panelists here joining us today, and we have a lot of information to get to, and I want to speed through just as quickly as I can some of the housekeeping information that I'll share here. As attendees of the webinar, just know that you don't have the ability to speak up during the webinar, but you will have the ability to submit questions to us using the chat pod. So I'll be monitoring that area as we go along. If it comes time that you have a question or you'd like us to elaborate on anything, I'll be monitoring that. Just let us know how we can help you. If you have issues with the webinar itself, the audio, the video feed, I'd encourage you to close out of the webinar and join back. You should be able to just pick up there, and that should help solve some of the problems. We are posting an archive of the webinar slides today at our archive page, fedbikeinfo.org/webinars. It's going to be in a PDF format. It should already be up, actually, if you check that page now. Within a couple of days, we'll also be posting the video recording. So if you want to look back at anything you may have missed, that will be available to you as a resource. We're going to be sending out a follow-up email later today that'll have a link to a certificate of attendance that you can generate for yourself. If you have others joining from your site, please circulate that email to them so they can also get that certificate of attendance. The email is also going to have a link to our webinar archive information just in case you miss it during today's webinar. We have a number of sessions coming up. One I'll mention in just a moment. The best way to stay up to date on what we have going on is to visit our website, fedbikeinfo.org/webinars. Follow along with us on Twitter. Hashtag PBIC webinar is the hashtag we'll be using to talk about the webinar today. And then finally, you can sign up for our mailing list at the link on the bottom of the page as a way to keep up with us. We have a webinar coming up on Thursday, a 2 to 3 p.m. Eastern time session on safety performance measures for bicyclists and pedestrians. So we're going to be kind of looking at safety in the macro level compared to what we'll be doing today. We're going to be joined by Amy Schick and David Kopacz from both NHTSA and the Federal Highway Administration. So you can visit our website to learn more about that webinar. Before we get right into the presentations, I do have a poll question that I wanted to open up for everybody, specifically to find out how many people are joining the webinar today. So if you could take a moment to cast your vote in this poll, it may just be you out there, or you may be with a small group of colleagues, 2 or 3 people, 4 or 5, or maybe even a larger group. We're just trying to better understand, how people are joining our webinars and participating. So once we have some votes, we will go ahead and move right along. Probably just a minute. I'll keep this open, and then we'll get right into the presentations. All right, just a few more seconds for the poll, and I'll go ahead and close it up. Really appreciate all of your feedback. Okay, that's enough for that poll. I'm going to go ahead and close it. Thanks for casting your votes in that. We will move right into our presentation now with Daniel Carter, Raghavan Srinivasan, and Kristen Norback all joining us. So thanks you all for being here and talking with us. And I think the way we wanted to frame the discussion before we show kind of the topics that we plan to get into today, first talking about safety effectiveness of countermeasures, what that means and really how we quantify that. We're going to talk a little bit about safety countermeasures and how we evaluate them, and how those kind of form the basis for what we know as crash modification factors. Daniel will tell us a little bit about how we can find and use crash modification factors, and then we'll close out with a more detailed discussion about some of the challenges that we face in really quantifying the safety effectiveness of pedestrian and bicyclist-focused countermeasures. So we'll get into it, and initially, to frame the discussion, I posed this idea that our challenge, a lot of us in our work in transportation agencies, is to make the best decisions that we can about safety improvements, given that we have a range of options, a range of numbers of sites that we could be addressing, but we have limited resources to use. And so Daniel, with that challenge in mind that I think many of our attendees are facing, you might be able to talk to us a little bit and kick this off.
Sure, yeah, so I mean, a lot of agencies recognizing that they want their decisions really be driven by data, by quantitative known effects of things. And so it's sort of a typical setup here of a benefit cost analysis, and you want to see, what are the benefits, what are the costs associated with whatever countermeasure you're entertaining. And so, Dan, if you would go ahead and show, we've got different kinds of benefits and different kinds of costs, and I want to mention those. We are going to be focusing on the benefit side of this, and so, the first bullet there, obviously we want a safety benefit from the countermeasure. We want to bring down crashes or bring down the severity of the crashes. There might be other benefits depending on what kind of countermeasure it is. We might see an increase in mobility, might see an effect of reducing congestion. Again, it kind of depends what it is. Might be other things there. For the cost side, I think a lot of you are very familiar with what would be entailed here. So you've got your startup installation cost, you've got possibly an ongoing maintenance cost depending on what you put in or the operation of it. So if it's something that's powered, lighted, you have an electricity cost there. So various things on the countermeasure cost side. And so quantifying these, of course, costs are pretty easy to quantify, but it's the benefits we're talking about here. And so that's what we want to use as we move forward. So for the benefits, the top left there, just in general, preventing crashes, and we can we'll talk more about this through this webinar about using CMFs to estimate what percentage of crashes would you prevent. But on the right side, we're also thinking, well, maybe it doesn't change the total number of crashes that are occurring, but it changes how severe the crashes are that are occurring. And so we see this in a number of improvements you might make, and even just a few examples there. A traffic signal installation, you would actually in general expect to see an uptick in rear end crashes, but a decrease in the severe angle crashes or the T-bone crashes, the very severe ones. And so you have sort of this trade-off, a very acceptable trade-off to lower severity of what's happening. You see the same thing from red light phone enforcement and a number of other improvements. And then again, depending on what kind of countermeasure you're looking at, you might have other benefits like mobility, comfort, acceptability to the public, or what have you, even aesthetic improvements sometimes. So there's other things to consider here, but we're going to be focusing on the effect on crashes. So Dan has sort of alluded to our one of our main topics here, the crash modification factor, CMF. And just at the top of the screen there, giving you the succinct definition, it's a multiplicative factor. So we're talking about a number. It's used to compute the expected number of crashes after implementing a given countermeasure at a specific site. And I do want to emphasize the specific site. We're going to be looking at what makes a CMF or a countermeasure appropriate for a specific site. How can you know what number to use? The basic calculation is just looking at the expected crashes with the countermeasure over the expected crashes without the countermeasure. And so if you've got, shown at the bottom there, a CMF that's greater than 1, this would show you that you would expect an increase in crashes following whatever the change would be. And if it's less than 1, it would indicate a decrease in crashes because the expected crashes with the countermeasure would be fewer than those without.
We got a couple of quiz questions, I guess we can pose to the group, kind of based on that definition. We don't have the ability for you to kind of cast your vote. You can type it in and send it to us if you like. But which of the following CMFs listed as A, B, or C would you expect to indicate a reduction of 25% of crashes? So an expected crash reduction of 25%. If you're thinking about the definition of crash modification factors, just getting everybody on the same page here, what would you think would be the correct answer to reduce crashes by 25%? And Daniel, our answer is C in this case.
Yeah, so to keep in mind, it's a multiplicative factor. So let's say you had 10 crashes per year occurring at a specific site, and you were going to use this countermeasure that has a CMF where it's going to bring about a reduction of 25%. Well, you'd be multiplying that 10 crashes per year by the 0.75, and that would show you in the following years what you'd expect, which would be 7.5 crashes per year.
Sure. And based on the responses I did get, we have some CMF experts in the house today, so good job, everybody. And now we'll ask another question, kind of flip it around. If we have a treatment that has a CMF, a crash modification factor of 1.25, and we applied it at a given site, how might we expect the crashes at that site to change? So would they decrease by 25%, increase by 25%, increase by 75%? So you can take the time to answer this on your own or in the chat pod, but the answer here, Daniel, is B.
Right, so we've got a CMF of greater than 1 showing an increase in crashes, and it's greater by 0.25, so 25% increase.
Yeah. And you may be familiar with the term, folks out there, about crash reduction factor and crash modification factor. You're going to get into some of that later, so I won't touch on that too much just yet. Yeah, we'll see an example. Those are two different terms meaning different things, but they're sort of the inverse of one another in a way.
Two sides of the same coin. Yeah.
Two sides of the same coin.
Yeah, so we're just going to highlight a few examples of countermeasures, particularly pedestrian-focused countermeasures that have been parts of recent studies, evaluation studies, such as the types that Srini will talk about in a little bit. So leading pedestrian interval, and this is the pedestrian head start to begin crossing the street, and this is a recent, and it's not quite published yet, but from Federal Highway, a before and after study to look at the effect of the LPI timing and develop CMF for that. Also, protected left turn phasing was part of the same study to look at for those green arrow protected left turns, what effect does that have on pedestrian crashes, with a desire to see if there could be a pedestrian crash CMF to go with that. And then from a recently completed CMF study that we did for NCHRP, we looked at 4 different pedestrian focused countermeasures, and so showing top left, the advanced, that's an advanced yield marking. We also looked at advanced stop markings before crosswalks. And these are all, I should say, at unsignalized, no traffic signal types of crossings. On the top right, we have a pedestrian hybrid beacon, or you might call it a hawk signal. Bottom left, a pedestrian refuge island as a sort of a breaking point there between the two sides of the road as the pedestrian crosses. And then on the bottom right, a rectangular rapid flashing beacon. So that little light that you can kind of see there strobes back and forth, also called RRFB.
Yeah, and I'll mention Charlie's here with us. Charlie kind of led the study to develop some of these, and we can answer some questions about it later. Charlie's got a lot of good information. He's got the report sitting right in front of him actually right now. So just a few examples of some that have been developed more recently. We're going to talk a little bit about all of the CMS that are out there and where you can find those in a moment. But the factors that we just talked about, you can find those numeric qualities or values for each of these countermeasures and more out there. But we wanted to start with CMS and then really think about, we often see these numbers and don't really know where they come from. And so I think it's important to really dissect the process that we use to evaluate and then develop a CMF. And so Srini is going to be talking with us a bit about that. And really, it all starts with safety evaluation. Srini, is that right?
Yeah, so I'm going to talk about evaluation, talk about different approaches, the pros and cons of different ways of conducting a safety evaluation. So number one, evaluation is important because if you don't do an evaluation, you have very little knowledge about how effective a treatment is. And so it's important that before you actually plan the project and do an installation, that you have funds set aside to do a proper evaluation. And then why do we evaluate our projects? One, as I said, you want to know how effective it is, and then by conducting an evaluation, you're getting a crash modification factor. You have information that other agencies can use to, decide whether they can, implement the treatment in their roads or intersections. And also by conducting an evaluation, you demonstrate the value to decision makers, and then who can, the people who provide the funds for implementation. Okay, so this is just an example of a treatment that was implemented in North Carolina, and this is the before condition where you have it's a minor road stop control intersection, and it shows a collision diagram. Now, the treatment here was going from a minor road stop control intersection to an all-way stop control intersection. But I should say that this is not necessarily an example of a typical treatment for reducing pedestrian crashes, but this is just an illustration to show that you can do a similar exercise for any kind of treatment that you want to, evaluate. So what you have here is a collision diagram before and an after. It shows, the different types of crashes that happened before the treatment was put in, and on the crashes that happened after the treatment was put in. And it's pretty clear, just looking at the numbers, that you have, a large reduction in the number of crashes and even the change in the type of crashes that happened from before to the after. But what we don't know just with this diagram is we don't know whether this reduction is simply due to the treatment or something else that may have happened at the same time. So that's the reason, you have to do a proper evaluation, make sure that you have, an accurate assessment of what really happened and what is the effect of the treatment. Okay, so what you're trying to do is to measure the true effect of a countermeasure, and we want to figure out, the crash modification factor should be a reflection of the treatment alone, and you have to account for the other factors that might, that potentially could lead to a change in crashes that may happen at the same time. Okay. Now, so what are these factors? Okay. Now, so for example, there could be other co-treatments that happen at the same time. For example, here it could be a speed enforcement campaign at the same time as putting a road diet, or maybe there was a change in how crash reporting is conducted at a particular location, a particular jurisdiction. Recently, many states, for example, have gone in and changed the threshold for when a crash needs to be reported. And some agencies use $1,000 minimum damage for a crash to be reported. Some use $1,500, some use $500. And they have those numbers have changed over time. And so when such changes happen, obviously that can change the number of crashes that are reported. Mm-hmm. Okay. Changes in exposure, traffic volume, pedestrian bike volumes could change. It could increase. Some cases could decrease, and that needs to be that could cause a change in crashes. Regression to the mean, that's something that we're going to pay some attention to. It's an important potential for bias that needs to be accounted for when you do this type of evaluation. Underlying trends in crashes, changes to the economy. In many agencies, they actually saw a decrease in crashes towards the end of the 2008, 2009, 2010 timeframe, and some places the numbers have started going up. As the economy has improved, so that needs to be taken into account. Other factors, for example, changes in weather. More snow or rain in few years. Either before or after can change the number of crashes that happen. The question is, what is the best way to account for these factors? Again, and I'm going to talk about, we talked about many factors in the previous slide, but one thing that's important is something called regression of the mean. Now, what exactly is that? Now, crashes are random events that naturally fluctuate over time. A particular location may have 0 crashes one year, 3 crashes next year, 5 the following, and 2 the following, with almost no change in either volume or weather or anything like that, because these are random events. Okay, so this regression of the mean phenomenon refers to the phenomenon averaging out. And so if you don't account for this, then you might confuse the random change that's happening in the site with the real change. What we are looking to estimate is the real change, not the random change. We want to account for the random change. Okay, so often agencies, they would say, okay, I'm going to take a bunch of sites, I'm going to treat the sites that have the most number of crashes, or the high crash locations. So when you do that, what happens is, because of regression to the mean, very likely the following years you may have crashes that are much lower than normal. So you're going to confuse, you might think, oh, the treatment has been very, very effective. On the other hand, it may have had little effect or no effect, right? Okay, so this graph here kind of illustrates the same thing that we had in text in the previous slide. So what you have is the blue line is kind of the long-term average crash frequency, and the green lines represent the short-term average crash frequency, and the red squares are the yearly crashes that happen at a particular site. Now, this is a hypothetical graph, but this is something that happens typically in a real location. So one thing this indicates is that the long-term average value, the blue line, may not necessarily coincide with the green lines. Okay, and that's because of regression to the mean bias. Okay, now I want to talk about two study designs, and what I talked about so far is when you do a before-after evaluation, it's a very common evaluation a lot of agencies do. Okay, I'm going to put a treatment in. I want to see how many crashes were there before, how many crashes after. It's a very common type of design. But also later, we're going to talk about the cross-sectional one as well. And which method you choose might depend on the type of treatment that is being implemented, number of sites where it's been implemented, the type of location, available data. Do you have data from before the installation? If you don't have any data from before the installation, it's kind of hard to do a before-after evaluation. Right. So, so it depends on the particular situation. Okay, so in a before-after evaluation, you try to figure out, okay, you have crashes before and crashes after, you compare them, you try to figure out what is the effect of the treatment. But if you do a simple before-after, it's also called as a naive before-after, it doesn't account for a lot of the biases we talked about earlier, like the regression to mean bias, or changes in traffic volume or exposure, or other changes that happen at the same time, like changes in enforcement or changes in crash reporting. So you use a different method, use a before-after, still a before-after evaluation, along with either reference or comparison group. And this is not one method, but it's a family of methods. And more recently, people have used the term empirical base, and that method has been found to account for a lot of the biases that I talked about, and like regression to the mean, changes in traffic volume, and is found to give a more realistic estimate of the actual effect of a treatment.
Okay. So just to stop there, the term you mentioned there, empirical base, is a term that will come up that people may hear time and time again. It really does, in general terms, refers to these family of methods that you can use to get a better estimate for what we'll show in a moment.
Right.
An EB estimate is sometimes that you'll hear that term.
That's right.
Empirical base.
Okay. So here, when you do a naive before-after or a simple before-after, so what you have is the three blue squares there. They represent the crashes in the before period, and then you have the treatment that was implemented, and then you have these purple squares, which are the crashes in the after period. Okay, and when you do a naive before-after, what you're assuming is that the blue squares would represent, essentially, you just need to compare the blue squares with the purple squares and say that is the benefit due to the treatment. You see, what you're saying is that if the treatment had not happened, the same number of crashes would have happened in the after period as well. Okay. Now the question is the assumption realistic? And based on what we all talked about, regression to mean bias, changes in exposure, other changes, in most cases, that is not a realistic assumption. Okay. And so what you do is, with more advanced methods, such as which makes use of reference groups and comparison groups, you estimate the expected number of crashes in the after period had the treatment not been implemented. And this estimate accounts for regression to mean bias. It accounts for changes in exposure. So you have to have the data for all these things. That's the reason you want to have the exposure data before the treatment, after the treatment, so you can make these estimates and get better estimates of the expected number of crashes had the treatment not implemented. And then you compare these expected crashes with the actual crashes that occurred, and that gives you an assessment of the real difference in crash counts that happened due to the treatment.
Yeah. So this is probably a good place to just pause and answer a couple of questions that tend to come up. So when you talk about these orange squares here, these expected sort of estimated expected crashes that you should have expected to get in the after period had you not done the treatment. Different than just assuming that they would have stayed the same.
Right, that's right.
Largely, and it's very complex the way that these are calculated. However, it does seem that they hinge a lot on exposure, the volumes of. In our case, we're thinking about pedestrian and bicyclist treatments, for example, the pedestrian and bicycle volumes and how those changed, and how the motor vehicle volumes changed as well.
And that is obviously an important component. And then regression to the mean bias, that's another component. And then any other changes that may have happened in the area. And by having a reference or a comparison group in that area, you account for other changes that may have happened.
Okay. So you're measuring the difference between your expected, based on these methods and your prediction, and what actually happened. And that's your real difference in crash counts. And we've got a hypothetical example to walk through here.
So just a hypothetical example, let's say what you have is you have either one site or a group of sites. You have the expected crashes without the treatment in the after period. And this one has a decimal. That's because it's an estimate that's come out of a statistical procedure. It's not an actual number, right? Okay, and then so the next thing that you need to know is the actual number of crashes that happened. These are the measured number. That's why it's 82 crashes. It's a round number, right? And then if you have these numbers, then you can estimate, what is the benefit due to the treatment. So if you subtract the expected and the actual, you see that there are 14.2 crashes were reduced due to the treatment. Okay. Another way to express this is a crash modification factor that Daniel talked about. So there'll be the ratio of the actual to the expected. And this turns out to be 0.85, representing a 15% reduction in crashes due to the treatment.
Right. So this is probably a good place. So we're already getting some questions about this. Let's go back. Where do we if an agency is out there wanting to do a really good, really high quality evaluation that you've laid out here, which is when we get to the CMF clearinghouse, these are the high star rated CMFs. These are the best, the most reliable ones. So if an agency is interested in doing this, is this estimate, this empirical based estimate for the expected number of crashes, something that an agency could realistically calculate themselves? Where would they go to find that sort of information? In as simple terms as you could.
Right. I think there are different components to it. Number one is the data. As Dan, you mentioned already about the fact that having the traffic volume data before and after, so that you can estimate the change due to that. And then that's number one. And then there's something that we didn't talk about in this seminar, something called safety performance functions, that represent, how do crashes change due to exposure. So these are the mathematical equations. Those equations have been developed, they're available from the Highway Safety Manual, that are available from other agencies. So you have that's another component. And then you have to have the expertise to be able to use all of those and do the calculation so that you can estimate this number. And there are, for example, projects that FSAA has funded, where they actually pick, a treatment that they feel, it doesn't have a good CMF. And then they actually go in and collect data from multiple agencies and they conduct an evaluation. The NCHRP project that Charlie led was also another example where, we selected 4 treatments for which we didn't have CMFs. So, and we collected data from many agencies to conduct this evaluation.
Yeah. So, but at the end of the day, I think that one of the takeaways seems to be that this method, while we point to it as probably the best way to really develop a true understanding of the effect of a countermeasure, and Daniel, I'm bringing you back into the discussion too, it may not be that every agency can conduct an evaluation like this, just simply because of the not only the data needs, but the expertise and some of the time commitment it would take to do some really robust evaluation. Which is why I think one of your points is to identify some of the biases that we should keep in mind, while also not necessarily saying we could move totally away from a simple before after, which is something that an agency, real transportation agency, is maybe more likely to be able to conduct.
A lot of agencies are still do that. There's no harm because you still get an assessment. For example, if you find that you put a new treatment that you've not done before, the crashes start increasing, then at least, it's just a simple naive way to tell you that maybe something is not working right the way you would expect it. So they do have value. And also by having this data when you do a naive, simple before after evaluation, you can take this data and in the future conduct a more robust evaluation. So if you save this data in your files, then it's a lot of value to others who are in the future can conduct a more robust evaluation.
Well, I think a practitioner who doesn't have the kind of level of statistical expertise that Srini does could even take a few lessons from here, right. Which is if let's say like your example, just a single site, you did something, you're tracking just the before and after, maybe 3 years before, 3 years after, and you see the crashes go up, and okay, maybe this isn't working. But you could also reach out and look at 10 other intersections that are similar and see what happened to those intersections, and kind of at least kind of get some context for what's happening maybe in the city or that sort of thing. Mm-hmm. The other thing is, Srini, you're talking about the regression of the mean bias, and a lot of times that comes into play because an agency selected a site to receive a safety treatment because it had a lot of crashes, which is to say it had a lot of potential to come back down too, based on sort of random fluctuation. So perhaps if an agency, if you're out there and you're interested in the effectiveness of something and you want to try it out, maybe select a few sites that don't have very, very high crashes. They're more maybe representative of an average site. You could kind of try to decrease that bias some and get a little bit more of a realistic feel for what might be there. But I think really maybe one of the takeaway points is that, if you're just getting kind of a real simple before and after take, just understand that there are other things coming into play there. The full decrease or increase you might be seeing could be affected by other stuff as well.
Sure. Yeah.
And also I want to mention along the same lines, I know that Federal Highway has been in the process of conducting developing training materials to see how practitioners can actually use these methods. They will need some input, they will need the data, they will need the safety performance functions. So these training courses talk about what data need to be collected, mm-hmm. and how can they identify a safety performance function that someone else has developed, and how can they use it in their own evaluation. And once you get those pieces in place, how can they conduct this type of evaluation? So I think these tools also, although they are involved, are getting more and more into a kind of a toolbook for a practitioner.
Sure. And those who may have some capability of performing some of this evaluation, or maybe have the data, can you point to any tools that might be out? Is safety? I know safety analyst is always talked about in conjunction with
yes.
the highway safety manual as one tool.
The safety analyst is something that can conduct before after evaluations. It is one of the modules, I believe, and I haven't used it in a while, but they used to have 4 modules, and one of them was an evaluation module. And there are also guidance documents that have been published, both by FSAA and by NCHRP, and that they are, I think, linked to the clearinghouse, I believe. So Daniel might be able to talk about it, when he comes back. So they actually also talk about, if you have the expertise, you can go through, read those documents, and then maybe start planning your evaluation.
Right. Okay. And is there, back on the topic before we move along, about how someone could go about really getting to the next level of calculating these expected crashes? Is the best way to, what I'm thinking about is looking at a study, like one of the studies that maybe Daniel will show us how to access in the clearinghouse, and really just reading up on how they calculated those values.
Certainly, that definitely would help, and the guidance documents also, because sometimes these reports, they may not tell you every single calculation, because you might refer to other guidance documents. So I think reading some of the reports, the NCHRP report, the Charlie's report might be a good example, but also other guidance documents.
Because the method will vary quite a bit based on the type of treatment you're talking about, the types of locations that are being evaluated. There's not one standard source for all that information.
going back to Daniel's comment about how sites are selected, sometimes agencies might do a kind of systemic treatment.
Okay.
Where they don't select based on crash count, but based on risk factor, or they may do a systematic treatment where they treat pretty much all types of intersections, all intersections of a particular type. If for those situations your bias to the regression of the mean is much lower, or maybe even non-existent, so the way we approach the evaluation may be a little bit different.
Okay.
So
let's come back to some of these questions because I think they're valuable. But your next set of slides, Srini, talk a little bit more about a different study design.
Yes. Yeah. The cross-sectional study design, so far we have pretty much covered the before-after one, which is the more common one for a lot of agencies when they put in a treatment, just tracking the before and after. The cross-sectional study design has a value, has an importance as well, because before-after may not be possible in many cases. In our case, you may not have the data. You may not be able to find data from the before the treatment was implemented. So you may not be able to conduct a before-after evaluation. So you conduct a cross-sectional study. What you do in a cross-sectional study is you find a group of sites without the treatment, and then you find a group of sites with the treatment and compare the crash performance on those two groups. And when you do this thing, what you want to do ideally is to have two groups of studies that are otherwise similar except the treatment. Okay, and what you see here, I guess, in the slide is one which is a 4-lane undivided road in the top, and then you have a 3-lane road, right? Kind of a road diet. Okay, and essentially here you're trying to figure out how effective is the road diet potentially in reducing crashes compared to the 4-lane undivided road, and you want to try to see if you can get locations that are somewhat similar, other than the treatment.
But these are not the same, right?
These are not the same roads.
Two pictures.
Yeah, two different pictures from two different locations, but you want to try to see if you can find, the characteristics are similar: traffic volume, type of area, and so on. Okay, but one thing with the cross-sectional study design is because it is comparing two different groups, there's always this question of are the results that you're getting based on a causal inference, or is it just a comparison, or is it just a comparison of two types of groups? Are the safety effect truly a causal interpretation? And so that's the reason there has been I would say a lot of debate in the safety community about whether these cross-sectional studies can give you a reliable crash modification factor. Okay.
And you mentioned some of the work that's being done now.
And so, and to overcome some of these limitations of cross-sectional studies, there are some methods that are being talked about. One method is called the propensity score matching method, where you have a very formal way of trying to match so-called untreated sites with treated sites. Of course, we do one thing that a lot of people do is, okay, is the traffic volume approximately same for what these groups are for with the treated sites with untreated sites? Is areas type similar? The propensity score matching method is a more formal method trying to see, okay, is one comparison site, untreated site, closer to the treatment site compared to another untreated site. So this method has been shown to provide, they've done some simulation analysis to show that this type of propensity score matching seems to give a more reliable CMF compared to a more traditional cross-sectional method. And still, this is the ongoing research, and this method has been used in other fields, in medical fields and public health areas, and is becoming more and more common in the highway safety field as well for conducting these cross-sectional studies.
And the real value in improving the quality of a cross-sectional study, the methodologies we can use, is it still for this reason that since we have so little information sometimes on the installation dates, on the volumes, on counts, that we just don't have some of this information, by improving the cross-sectional study design, we may be able to do much better evaluation, even still with limited data.
Right, even without much data on the before period.
Okay. So the question, and we're going to come back to some of these questions you all have about developing crash modification factors. But the good news, I guess the good news is for a lot of us, we don't necessarily have to just go develop all of our own CMFs every single time we do projects, right? Because that's for that reason, because we know that's a very difficult process, FHWA, NCHRP, a number of other funding agencies have supported the development of crash modification factors that if we know them, if we are fairly confident in that factor, and we know how to find them and use them, we can take those values instead of having to conduct them ourselves and collect them ourselves. So Daniel, you're going to share a bit of information with us about kind of how you can go about looking at CMFs and really deciding between them and really in using some of the countermeasure resources that we have available, many of them that are listed here on the screen. We've done webinars on PedSafe and BikeSafe, both fairly recent tools that are being updated with effectiveness of pedestrian and bicyclist safety treatments, not only in CMF's terms, but other measures of effectiveness like speed reduction and conflict reduction and things like that. Highway Safety Manual catalogs a lot of these, and they come out of these reports like those from NCHRP. But you're going to sort of take us into a little bit of depth on the CMS Clearinghouse.
Going to delve into my favorite one, in no way affected by the fact that I've been the manager of it for 7 years. Yeah, definitely. So let's talk about, there's a lot out there. As you mentioned, Dan, there's a lot of work, a lot of research that's been done to develop CMFs. And so one of the things I wanted to highlight was, how do you find what you're looking for? How do you go and particularly how do you use the clearinghouse to do that? Yeah. So just to kind of take a little bit of a quick tour here, and definitely will refer you to exploring on your own later on. But first of all, www.cmfclearinghouse.org to get there. And so we've got it laid out where you can begin your search there, and in particular, search for whatever type of countermeasure you're interested in. So, you mentioned some of the ones before. We've got pedestrian hybrid beacon, other types of countermeasures that you might be interested in. Actually, back up one just real quick. At the top bar there, I encourage you to explore, and we're not going to do it here, but there are some things there, and in particular, under developing CMFs are some of the resources that Srini mentioned. If you're interested in doing some evaluations and developing some CMFs, there are those resources there. So when you do your search, so Dan had done a search for pedestrian hybrid beacon, and you'll see there's sort of an expanding, collapsing set of search results that you can dive into to see what you ended up with. And when you drill down through that, you'll see what CMFs are available. And so we're going to look at these 4 entries here under install pedestrian hybrid beacon. So on the far left of each row, we can see what the CMF is. The first one there, 0.712, so that's less than 1. So that indicates a decrease in crashes, and it's a decrease of about 29%. And that's, Dan alluded to, the use of CRF, and that's something that was used more traditionally by a lot of cities and states, which is just to refer to the percent reduction. So this is a crash reduction factor. And as I mentioned, 2 sides of the same coin. A CMF of 0.71 is a reduction of 29%. It's the same way, just phrased 2 different ways. And so we put those both there. Moving over from that, you can see the stars that are given to each of the CMFs. And this is something that's done by the CMF Clearinghouse team, by the knowledgeable and expert reviewers to look at the study, how well they did it, what kind of design did they use, as Srini talked through some of these biases, did they address those, how big sample did they use, this kind of stuff, and all that factors into a star rating. And the takeaway point is here, the higher stars, the more reliable the CMF. So we're not talking about the reliability of the countermeasure to reduce crashes. We're talking about that number right there, the 0.71. How much faith can you have in that number being a very true representation of what this PHB will do? 4 stars is a fairly high rating, so that's saying this is a pretty reliable CMF.
If we can pause just there on the star rating. The star rating is something that comes up a lot. People look at the CMF Clearinghouse, lots of questions about the star rating. What do those mean? And I will say there's a guide on the page that gives a full look at the star rating system.
You can go in under that top bar that I mentioned before on the web page. If you go under about the Clearinghouse, you can look at the details about what we do when we do this star quality. But we look at the study design, the sample size, standard error, which is a kind of a statistical measure, the source of the data, and other potential biases, and we'll sort of boil it all together to try to make something that conveys easily in 5 stars.
And it kind of gets back to some of the different methods that Srini was laying out to us, from the very simple before and after, maybe being on the lower end of the star rating, simply because of all the other biases that may be in there, and then at the other end of the spectrum, an empirical base accounting for all of potential biases being a higher star rating.
Sure, you got an empirical-based study that had a large sample, very rigorously done, avoided potential biases, boom, 5 stars, and then you kind of go down from there. Okay. So you also, though, I want to make sure that when you look at these CMFs, that you don't just look at that left side and say, oh, I'm going to look at these numbers here, but you really want to see what type of crashes are those numbers referring to, because you can see how they're all different. For example, the first row, the 0.71 we've been talking about, addresses all crash types and all crash severities. And so the way to understand this is to say that if you put in a PHB, you would see a 29% reduction in just all crashes at the site. Total amount of crashes, all types of crashes combined. The next one, though, on the second row, the 0.453, is to say you would see this kind of decrease. It's a decreasing CMF, decrease to vehicle to pedestrian crashes. So we're not talking about all kinds of crashes, just the vehicle to pedestrian crashes. And so just by comparing those first two, we can say, well, looks like PHB is much more effective at reducing vehicle to pedestrian crashes than just the general sort of population of crashes, which is great. That's what it was intended to do. So that's nice to see. Do look at the other fields, and there's actually, each of those numbers is clickable, and you can see a lot more data about the CMF behind each one. On this very summarized screen, we can just see things like the crash type, the crash severity. For example, that third one down is just addressing crash severities of K, A, B, and C, so injury crashes, not including the property damage only crashes.
That would be fatal crashes and then type A, B, and C injuries.
Right, exactly. So I do want to encourage you to look at the data, the details behind each CMF, because it's not just, don't ask the question what CMF is carried by this PHB. It's what CMFs are carried by the PHB, because it has different effects depending on what kind of crash type you're talking about.
And by clicking on one of the CMFs itself, that's where you can really dive into more information from the study and all that, which I've got some of that, just a snippet here.
Here's a good example here from a different, actually this is probably one of the CMFs that you just had on the page, I believe. So we can see a little bit more detail, so we can tell this was developed, this particular CMF was developed on minor arterials that were 2 to 8 lanes. You can see the date range used. Had a lot of states involved in it, so it was using the installations of the PHB across a lot of different states. So this tells you more about it, and in particular, let's say that the if the state was only Florida, and you're in a state where maybe the geography, the demographics you feel are pretty different than Florida, then maybe you might have a little bit more care in applying this CMF. You say, well, this is maybe a little bit different than what it would affect here, or if you're similar to Florida, you might have more confidence to use a CMF.
Right, and so just for everyone's knowledge, this is the second row, the Zagier et al. 2017, which was the study we've been mentioning. That's the detail included here, and there's a lot more on that page with really dissecting all elements of the study.
So takeaway point, look at the details, make sure it applies well to the site where you want to use this CMF. Yeah, so other features I wanted to highlight, if you pull down the About the CMF clearinghouse thing on the top bar, you'll see in particular one thing I want to highlight, which is the user guide. And so if you are new to this, if you're new to using the clearinghouse to try to find what you need, we've put together a user guide that is very much intended for those who are totally new to using the site. How do you search? How do you interpret what you've searched? Some of the things I've just talked through here. There's some videos there to even show you how it's done, just in a kind of in a live sense to watch something, watch the tour of the site. There's a few other features there. I've mentioned how to develop and use the CMFs. So there's also a few other resources kind of related to the use of CMFs, so kind of in the larger safety management realm. So SPS, which are safety performance functions, Srini mentioned those. There's resources on there if you're doing the cost benefit analysis like we opened this webinar with. And then this CMF clearinghouse is focused on infrastructure, engineering improvements, but we do link to other resources for behavioral countermeasures. So those kinds of safety programs that are looking at driver behaviors and that sort of thing. So those are also available.
One question that came up, Daniel, the question is that when you go into the CMF clearinghouse, you drill down to the level of, here, and you get to the study details page. Can folks access, in those cases, the original studies from this page? So if it's a NCHRP, a National Cooperative Highway Research Program report, if it's a Federal Highway Administration report. Generally, those are just free to access to anyone, but
Right.
I don't know if in every case, because there are lots of other sources of
Go back
research.
one slide. If you see the under reference, and each of those short references there are hyperlinked, so that will take you to the page of the study itself. And you're exactly right. If it's something that came from NCHRP, Federal Highway, a state DOT, that we have a number of CMS that were developed just from a state DOT doing their own internal study. Yeah, these will be ones where we are either linking to the page or we're just hosting the file. It's freely accessible. But we do look through a lot of professional journals, conference proceedings, and other things like that, where we can't, by copyright laws, we can't provide that full text, but at least we can show you where it would be, give you the citation. Maybe if you're a city you could work with, if you have some kind of library resources or something that might have access to that, or a local university you might could work with to get the full text of the article, because reading through the study can be very beneficial.
Yeah. So and then we showed a few of these. One thing that you always tell folks to do, Daniel, if they're interested in just dipping their toe into the SEMA clearinghouse, is from the home page, just do a blank search.
That's right.
Don't type anything into the search terms, search CMS. From that page, you'll get a lot of options to further drill down into subcategories, different types of crashes. So some questions coming in about, do you also have CMS for bicycle infrastructure? We'll get into some of that discussion in just a moment, but that's certainly one of the filters you can apply to simply just see all of the studies that are relevant for bicycle.
We implemented, right, because people kind of wanted to, in a sense, just flip through the book, right? That, kind of that idea. Well, it's a little bit tough with an online database. So our best attempt to do that was, if you just leave the search term blank, hit search CMS, you might want to give it a second. It's going to take 30, 45, 60 seconds, depending on how fast your computer is, to load it up, but it's going to give you the entire clearinghouse. And then you can just open and close those different categories, look under bike, look under ped, look under traffic control, explore and see what's there. And that can be an interesting, just to kind of get an overview.
The other question is, it is called the Crash Modification Factors Clearinghouse. So there are a lot of other methods you can use to do a safety evaluation, looking at what we sort of tend to refer to as safety surrogate measures, or factors that we know influence safety in some way, conflicts or speeds. If you look at driver behaviors, things like wearing a seatbelt, these are all safety surrogates. You can measure a change in one of those and then make some estimate about what that does for safety. The Crash Modification Factors Clearinghouse is really just including studies that show in some way a change in crashes, whether crash is increasing or decreasing. They're not going to include those types of sort of safety surrogate studies.
That's right, exactly. So we have certain eligibility criteria for any study that we find. It has to be based on crashes, it's the first word in the name there, and then it has to report CMFs, and it has to be based on infrastructure improvements, as I mentioned, is engineering focused here. So yeah, that's a good idea to give people an idea of what's scoped here.
Now, conversely, I'd say if that's the sort of, if you're looking at interest in looking at the effectiveness of a countermeasure, people are talking about traffic calming measures. Not a lot of, from what I understand at least, not a lot of crash modification factors for things like speed tables or chicanes or some other traffic calming type measures. However, they have been evaluated for other for impacts on other things like speeds and
yielding behavior, that kind of thing. Yeah, it's not going to be in the CMS clearinghouse, but there are studies on it.
So that's where some of those other sources that we mentioned come in handy. I think PedSafe and BikeSafe. The background of those resources is a fairly detailed literature review that looked at all relevant literature on safety effectiveness of any type of countermeasure, both crash and otherwise. So those would be better resources for finding everything that has to do with evaluating the safety of a particular treatment.
And another thing I want to add on this, if you potential change in, say, average speed due to your treatment, in the highway safety manual, in the first part of the highway safety manual, I think it's part A, there is a table that shows, for example, if a treatment leads, say, a reduction in speed of about 3 miles per hour or 5 miles per hour, what is the expected decrease in injury crashes or fatal crashes? And there's a table, that's based on a study. They use a method called meta-analysis, based on, I think, combining results from, I think, 50 or 60 studies. So that's another thing that tells you, you don't have a CMF available, but you know what is the expected reduction in average speed due to the treatment. You will go and use that table to get an assessment of what could be the safety benefit.
And I think getting back to connecting it with some of the discussion we had earlier is, while some of the safety surrogate studies, these are hugely beneficial, especially for measuring more quickly the impact of a treatment, measuring a change in yielding or a change in speed. You can do that much more quickly than you can if you have to wait for crashes actually to occur. Nobody wants to be in that position. But the other side of it is that when you talk about calculating cost benefit for projects and how a lot of typically state departments of transportation are talking about using safety funds is using treatments with CMFs to be able to calculate those real benefits from crash outcomes and making those kinds of decisions. So it keeps coming back to the fact that there is a demand, no matter how useful some of the other information can be, there's a demand for CMFs. We're going to get into that in just a moment. But you wanted to
segueing to my next.
You wanted to plug this discussion for tomorrow.
I do want to plug a webinar tomorrow. If you are interested in hearing a bit more about how to use the CMF clearinghouse and how to use CMFs in applying them in real-world situations, join us tomorrow. We've got a webinar at 2 o'clock Eastern. And the link, if you want to register and join us, this is a free webinar, and you can go to the clearinghouse, and there as the address shows here, clearinghouse.org/webinars.cfm, and you can click the link there under today's webinar and register for that and join us. We'd love to have you.
So, as I mentioned, that there's a lot of demand for good CMFs for that reason, is that they are typically used by state DOTs to kind of justify these investments. I did a little searching this morning and found, as of this morning, there are just over 6,000 crash modification factors in the clearinghouse. 59 of them are for pedestrian relevant treatments, and 179 CMFs for different types of bicycle treatments. And so it begs the question then, why are we lacking, I guess, so many pedestrian and bicycle focused crash modification factors? And you're going to lay out, Daniel, some of the reasons for that, along with
yeah, this is an excerpt, an email I got from a city engineer, and certainly this is not unfamiliar, I think, to a lot of people, that this person was running into issues getting state funding through the HSIP program for some pedestrian improvements in the city, specifically intersection bulb outs, and wasn't able to really get that because there were no star-rated CMFs that he could use to show a quantitative benefit to the bulb outs. And so this is just a sort of a showing the need to have CMFs, hard CMF actual values for these pedestrian and bicycle safety improvements.
And for everyone's knowledge, the searches on the CMF clearinghouse are tracked. You all take a look at those from time to time and come up with your own CMF most wanted list for things that people are looking for, and they just don't exist yet. Intersection bulb outs or curb extensions being one of them.
Yes, very much. Yeah, we look and see what are people looking for on the clearinghouse, and in particular, what are they looking for and not finding. And yeah, bulb outs or curb extensions has been on the top for quite a while. And in fact, what we call the most wanted list, those who are the CMFs that are most wanted by users, lots of them are pedestrian bicycle focused. So yeah, I just want to talk through, this question that you raised, Dan. Why aren't there more CMFs that are for ped and bike improvements? And so talk through some of the data needs and challenges. And I thought that might be kind of interesting for this crowd here. So just to kind of run down through it, so fewer sites. If you think about what goes into a quality CMF, or even making a CMF feasible at all to be developed, is to find places where whatever countermeasure you're thinking about has been implemented. So for example, the rapid flashing beacon, the rectangular rapid flashing beacon I mentioned at the beginning, we were doing an evaluation of it, and we had to find places, agencies that installed it, and that was a challenge because it was rather new and that sort of thing. Certainly we know that pedestrian and bicycle crashes are more rare than vehicle-to-vehicle crashes, just in terms of a sort of a sheer number there. While this is good, it does make studying the effect of the crashes difficult because you just have a smaller sample to work on. A lack of records can be an issue a lot of times, and so it depends on what kind of improvement you're talking about. But finding an agency maybe that has implemented a new treatment, maybe a set of installations, but didn't really keep track of when they put it in. Hopefully they know where they put them in, but a lack of records really does make a challenge for trying to evaluate. I mean, like Srini talked about the before and after study, of course, one of the key pieces is knowing when. So you can know when the before and after actually is. That's a challenge. And then I think a lot of people will know that the lack of exposure data is a challenge. So we're talking about pedestrian counts, bicycle counts. Knowing the amount of pedestrian traffic is important. As Srini was talking about, some of the challenges in doing a study is that you want to be able to track, did the volumes go up or down? What was the effect of volumes going up or down? And so you need that sort of data. And so that's another challenge. And this kind of touches on some of the you mentioned the traffic calming with CMS not really being available for that, and some of that has to do with the fact that crashes on those types of roads are more rare. Exposure data is more lacking because if it's maybe a less major road, the agency may not have collected pedestrian counts. So that sort of all that kind of brings together to make this a challenging topic. I guess I just really spent a lot of my words. I should have waited for these slides here, but so relatively new treatments, not a lot of states and cities trying, and this is a little bit of a catch-22 because a lot of practitioners, a lot of the attendees perhaps on the webinar, would like some CMFs for some of the new treatments, so you know what effect it has, but they're so new, they haven't really been installed very much, and so we can't study them. So kind of a little bit of a vicious circle there. So that's something that, and I'll kind of point to this later on, we really like to encourage people to try some new stuff, keep track of it, so we can be able to do an evaluation of that. So lack of records, I mentioned, I kind of talked through a little bit of that. In particular, the lower cost treatments, and these are of interest because if we can show that a low cost treatment has a good safety benefit, well, that's that'd be great. Let's implement that. But actually tracking low cost treatments is kind of tough. And so this is a picture of the leading pedestrian interval that I referred to at the beginning, the LPI. And it's a timing change. It's just changing the timing of the pedestrian signal, which is, depending on the agency and how you get your signal set up, not too difficult and can be done pretty quickly. And because of that, sometimes doesn't get recorded as to where and when it was done. And so this is a challenge. But we do need to know that date of installation.
Yeah, a question came up earlier about there's an increasing popularity, I think, or a trend in agencies doing more shorter term pop-up or temporary installations, trial installations of certain treatments. And I think those from a implementation standpoint are amazing because then you can do a lot more initially and go ahead and test it out before you commit to the full build out. However, I think from an evaluation standpoint, from a CMF development standpoint especially, your timeline all of a sudden is much shorter than you may have for maybe a 2 or 3 year in-place countermeasure. And so you may not be able to do a crash-based evaluation for something like that. That's probably where some things like surrogate measures, speeds, yielding conflicts, those sorts of things would be more beneficial.
Yeah, that's where you get the advantage of that kind of thing, because you can do it more quickly. You don't have to wait for years. I mean, this is really, as you can tell, we're having to look at installation safety treatments that have been in place for a number of years. Yeah. Right. Let's see. Okay, volume data. So I mentioned about the ped bike counting. It's not, I would say, a regular activity for a lot of states and cities. Sometimes done, maybe more in the downtown areas, that sort of thing, signalized intersections. Could be done by a research team, and we've done that as part of projects before. We wanted to evaluate, particularly this one I talked about with the unsignalized treatments, some of those crossing treatments. These weren't places where cities had done counts. These were unsignalized locations. They weren't really in that priority listing for counts. So we did do that as part of the research project. We employed people to go out there and take counts of pedestrians crossing, that sort of thing. It is expensive, and maybe more importantly, we have no time machines. You can't go back and count in a before period. And so if, let's say, putting in a type of crossing, maybe a pedestrian hybrid beacon, if we don't know what the pedestrian traffic was there before it went in, all we know is that after we can sort of count who's crossing there now. But if we see a decrease in crashes, or let's say we see an increase in crashes, well, do we know, did the volume of people crossing go up? I mean, if the volume of people crossing tripled, then seeing an increase in crashes, that might really help explain some of that. So it's an important piece of the whole puzzle here. Some cities do collect counts, and we've used some cities' data because they were collecting pedestrian counts, as this is pedestrian focused here, on a regular basis. So we've dealt with Charlotte here in North Carolina, Toronto, that had some good data available about crossings at intersections. It was something they did as part of their turning movement count regular program. Other cities, Chicago, Philadelphia, were collecting what I would call here mid-block sidewalk counts, so the flow along a sidewalk between two intersections, and so they were collecting it in that manner. And we can use that, and it's very helpful, but it's still not as widespread as we would really like to be able to study different kinds of treatments, because we're kind of in this sense limited to what Charlotte, Chicago, Philly, and Toronto have implemented. And if they haven't done a particular thing, and if someone else has, but they don't have counts, then it makes it hard to study. So again, just kind of outlining some of the challenges here. And then, of course, rare crashes, such as pedestrian and bicycle crashes, results in lower sample size. And so even if we were to find, sites where there was a safety improvement done, we really need to have a lot of years of data. So we need to study this thing maybe 5+ years before, 5+ years after, in order just simply to get an accumulation of number of crashes that we can use to give a read on, did this decrease crashes, did it increase crashes, can we say that it didn't do anything to crashes? It does take quite a bit of sample to be able to do that, and that's another challenging thing about that. So here's the call to action for all of you safety practitioners out there. What can you do about these challenges? So I mentioned that we a lot of times are lacking installations of new treatments, and so there you go, install new treatments, experimental things you want to look at the effect of, and you're thinking about installing them. Go ahead, put those in the ground, keep track of where they're at, and then that'll be available for researchers who might come knocking on your door saying, do you have installations of treatment X?
And this is one of those areas you talked about where it is that kind of catch-22. If an agency is moving away from installing treatments that don't have high-quality established crash modification factors and only installing the ones that do have them, the result may be that we don't install those treatments that we really need more data and more examples and good evaluations for. The takeaway is to continue to do those things that they don't maybe have CMS, but maybe they do have. That's getting back to our measurement of safety surrogates. Maybe there are indications that it reduces conflicts and speeds and other things that improve safety. We just need to know more about the crashes. Installing more of them can help us understand that.
Yeah, this is Charlie. I would add too that before you just randomly install treatments, because there aren't many of them installed, really try to understand the causes of the crashes or problems that are happening, and then choose your countermeasure to address that specific problem.
Right. That gets to a question, and I'm going to start maybe sprinkling some questions in here. We've been getting a lot over the course. You mentioned that you can drill down. Some CMFs are as specific as some are all crashes, and some are specific to vehicle pedestrian crashes, vehicle bicycle crashes. Some folks on the line are even more interested in getting more specific than that, and they're interested in, for example, a treatment that can be proven to be effective for crashes involving children at a school zone or individual older adults, something specifically that can be measured to be effective for that group. Individuals with disabilities, things like accessible pedestrian signals and audible pedestrian signals. Can the information we have currently on CMFs in the studies that we have get to that level of granularity, that level of detail, getting to Charlie's talking about specific causes, crash types maybe. Yeah. Can this CMF address some type of crash type, like a right hook crash for bicyclists? Mm-hmm. Any of them get that specific?
I mean, you look at, let's say that we go about evaluating a particular safety treatment, maybe a school zone related treatment. And, at each of these sites, you might see 1 crash a year, 0 crashes a year, depending on which year you're in. Over a 5-year period at each site, maybe you've got 6 crashes to work with. Now, how many of those are a specific type? Maybe just 1. And so now we've got a very, very low sample size. And that's why a lot of times on the clearinghouse for these pedestrian and bicycle focused CMFs, most of the moderately high rated ones will be addressing either all crashes, because that's kind of what could be done with the sample size, or just all pedestrian related crashes. So not specific to children or disabled or anything like that, but it's just sort of, there just wouldn't be enough there. Mm-hmm. Until you have a lot of sample available that you could do something to look at just a specific type of crash, you're kind of, by necessity, just going to be looking at all pedestrian crashes.
Okay. Yeah, one point that Dan mentioned earlier is not all countermeasures are specifically intended to improve safety. Some may be intended to reduce congestion or delay or even speed. And so just be a little careful. If you implement a countermeasure that's not really addressing safety, then you may not necessarily get a safety effect. But if it was intended to reduce delay, then maybe evaluate it based on delay. And so just keep that in mind.
Well, and the one thing you might want to see from a safety evaluation is that it's not causing a problem.
Right.
It's not increasing crashes.
Yes.
And so great, and this is so stepping out of the ped bike world for a minute, we did an evaluation of an agency that was converting their traffic signals from an incandescent bulb to an LED bulb. It was for energy purposes. It wasn't for safety. We did a safety evaluation and found no effect. It was a CMF of 1. It didn't do anything to crashes, which was a very usable answer, is to say, okay, if you want to convert for energy purposes, go right ahead. It's not causing a problem for crashes.
And to bring it back to the ped bike area, oftentimes it may be a more traditionally mindset, transportation person will say, well, if we add bike lanes to this road, more people are going to bike here, we're going to see an increase in crashes. That may be an argument that you hear, or do some other treatment that will attract more users to the road, and that will increase crashes as a result. But in those cases, you might be able to find a CMF of 1 for a particular treatment and say, look, the studies show that actually when this treatment is done, there was no increase in crashes. We can kind of use that as a way to bolster some argument in a way.
Yeah, researchers sometimes you find don't really like a CMF of 1, right? Because it's sort of the non-answer. But I think there is a benefit to that, because if you did it for some non-safety reason, well, you're showing there's not a problem. You can go forward with that. Okay, so here's another thing you could do, which would be to expand a counting program and where you're counting. So maybe you could try to implement this as a part of a regular turning movement count program, like we've seen some agencies do, or simply just employing maybe some technology to be able to do mid-block counts or what have you. But collecting more count data is going to enable research to be done in a much more rigorous fashion, or even able to be done at all.
Sure. And I think the key is that more data, but better data too, good data. And Krista and Rebecca, I wonder if I could bring you into the discussion here, because I know a lot of your work, you did a whole 2-part webinar series earlier this year on simply this idea, this whole topic of counting and volume data collection. And I think the impression is that we're seeing across the country the amount of data, the quality of data really improving, and even some efforts at the national level to begin to catalog this and make it available on a more widespread basis. I see, and based on what I've heard from our panelists here, the benefit really being that we, as a result, could get some much better evaluation and much better CMFs going in the future. How do you see that, the role of improving data kind of impacting this whole discussion on safety?
Yeah, I do see some signs for hope here, that we do see some jurisdictions doing a better job of counting bicyclists and pedestrians. And I want to specifically give the Philadelphia area as an example, where they're counting bicyclists and pedestrians for a week at their short duration count sites, and they also have a network of permanent bicycle and pedestrian counters. And having both the permanent and the short duration counts, where you're counting hopefully for at least a week at each site, can really give you a solid handle on what's going on at those sites. So if you're looking for something to copy, that's a pretty good program. For places where they're just starting to think about how do we count bicyclists and pedestrians, I like to say the first step is to put a permanent counter in somewhere so that you can get that what's going on right now and into the future. So when you start implementing some of these treatments that we've been talking about, you can then get some idea of what happened before. And it's also important to do your short duration counts, but building that first continuous counter where you're counting 365 days a year, 24 hours a day, bicyclists and pedestrians, will give you some basis for how weather is impacting your count. And some years may be lower than others just because of the weather. So it's really important to get that counter installed as soon as possible and start building a whole complete program with both permanent and short duration counts.
Great. That's really important, I think. And I'll ask some of you, Charlie and Daniel and Srini, but in conducting some studies, I imagine, I know for some of the studies, you start out with a whole list of countermeasures that you think we want to be able to develop crash modification factors for each of these. Over time, that list may narrow based on the amount of data that you can find. Is it in some cases just the places where there were a lot of installations maybe just lacked that volume data collection, those counts, it's just hard to really do a lot of evaluation without that exposure metric.
Yeah, certainly finding that overlap is key. I mean, when you look at doing evaluations of safety improvements in the vehicle domain, we can pretty much count on having AADT or traffic volume at most locations, and it's not usually a constraint. But in the pedestrian and bicycle evaluation, we really, if we're trying to work on a limited research budget, have to work within those places where there's existing count data.
Yeah. So the message to state and local agencies that are considering installing certain treatments is, if you can do a count, like a ped bike count, if you're doing a pedestrian bike treatment before the treatment's installed, and then of course also a count afterwards, that will really help with you being able to conduct a better evaluation.
Right. So Krista, another question for you. You and I had talked about some things that an agency might be keeping track of to monitor over time when they do install treatments. Beyond the counting issue, it's the detailed records of what they're doing. And Daniel, your recommendation is to keep detailed records. And I wonder if Krista and Daniel and Srini and others here have items that you would say, if you were to keep only some information when you install treatments, when you install projects, which ones would be on that list of things? If you're building this database of records of all your projects that you're doing, what would you want to make sure you're capturing?
What, where, and when. You get those three pieces, I'll be a pretty happy camper. I can work with everything else, but the what, where, and when is the big pieces that are tough to find out.
Also, if something else is being done at the same time, the transit treatment, like maybe either a year before, a year after, what else is going on the site? So, right, that will be very valuable as well.
Krista, did you have one to add to the list?
I think that we've had a really good discussion on all these things, and emphasizing when the treatment was installed, I think is a good missing piece we definitely need to record. So yeah, the exposure data, the crash data, and the facility data. Those are our big three.
And sometimes we find that a lot of people who would like to use the CMF, for example, let's go back to the LPI. They're interested to know, well, the LPI that you evaluated, was that a 3-second head start? Was it a 5 or 7? And if we don't know from the agency, at each location, what kind of head start did you give them? We can't use that. So details like that are important when people want to take and use the CMF later.
Right. The point is brought up about the economic side of this, costs of some of these things. So certainly, you think in one way about evaluating. We're talking about evaluating for safety, but you can evaluate. A lot of people are beginning to evaluate the economic consequences or benefits from some of these treatments. But if you're thinking about costs, monitoring the cost of projects can be very useful too. We get a lot of questions, Charlie, you especially, I think, get a lot of questions about how much something will cost. What's the startup cost, the maintenance cost over the lifespan of the treatment. You even, Charlie, co-published a paper some years back that looked nationwide at all the different costs for different types of treatments from location to location, and tried to summarize those in a way. But that's something that's so specific to a type of treatment, to the lifespan of it, whether it is that installation versus the lifetime cost, where in the country you're located. What recommendations, is that something, I guess, that an agency should capture, is that the cost of how much we spent on this particular thing, maybe the bid or some other record to capture?
Yeah, I mean, that's certainly good to know for your local agency, for a type of countermeasure that you plan to use more of in the future. Dan mentioned the report. It's called Pedestrian Bike Countermeasure Cost Guide, and then you can probably send a link to it. Yeah, the other thing that I think is important to keep in mind is, with many countermeasures, they don't work universally the same at every kind of location. And just, we learned many years ago, just mark crosswalks. I mean, we learned that, it's okay to put them in most, 2-lane road situations, especially lower speed. But on multi-lane roads, you often need a lot, different countermeasures, something more substantial. So keeping track of, the number of lanes, the speed limit, and some of the, location conditions, is important.
Mm-hmm. Yeah, absolutely. The final challenge, data challenge that you identified in keeping ped bike CMS from being developed was the rarity of crashes. And so what, in terms of a recommendation for an agency,
we do not, I want to be clear, we do not recommend that you increase your pedestrian crashes in your agency so we can study things. Yeah, not much to do there. We do hope that the crashes continue to decrease, and hopefully we'll make up with the fact that we have a lot more installations with better records and better counts so that we can study those things.
Right. Yeah, that's one that I think by doing some of these other things, we'll be able to address a big part of the problem. There's a lot of questions about cities and states. Should they be thinking more about developing their own crash modification factors on their own projects with really high quality, robust evaluation, or is there a good amount of reliable information out there with the CMF Clearinghouse, the PedSafe and BikeSafe, and a number of other tools that it's really more important, I think, for them to understand how CMFs work, how to understand the applicability of the results, where the studies were done, and really how best to use the established CMFs. Those seem to be two things that could both happen, but you got to think about where to put your investment. Is it in the really high quality, robust evaluation, or is it in figuring out how best to use the knowledge that's coming out of the research world? And this is not a right or wrong answer, just your opinions.
Well, and maybe Trini can address this, but something we learned from the NCHRP study, evaluating the 4 treatments, NCHRP 841, is with one of the treatments, RFPs, we had only about 50 sites. And even though that sounds like a lot of sites, that was barely enough sites with the number of crashes to even be able to come up with a CMF. So, I don't want to leave the impression that if someone treated 1 or 2 sites that they automatically can do a good, CMF development. That it often does take dozens of sites or even hundreds of sites for certain kinds of treatments. Because as Srini can say in more detail, the least the amount of effectiveness of a given treatment, the more sites you would need in order to find the result to be statistically significant.
Mm-hmm.
So I think maybe the answer to your question, Dan, is certainly it's good to start out with understanding the CMS Clearinghouse and making use of that as best you can. And then in cases where you have either used a lot of a certain treatment or you plan on using a lot of a certain treatment, dozens or maybe even 100 or more of a given treatment, then you start to have the sample sizes, particularly for pedestrian bike crashes, that will allow you to conduct an evaluation.
I think that's a really interesting question. It's a hard thing to think about. Where do you start and exactly how far do you put funds toward evaluation as opposed to actually putting things in the ground? I think if you can conduct maybe some simple evaluations and understand some of the how to interpret those results enough to kind of give you some feel for how well a treatment is doing, as well as conducting, as you mentioned, surrogate studies, maybe an effect on speeds, yielding behaviors, or a number of crossings using the crosswalk or whatever you might want to use, enough to give you some corroboration that, yeah, I think this is actually doing some good on the safety end. I think this is having a good effect. I think the other part would be then to keep those records, even if you're not going to be conducting this really full-out empirical based before and after large study, keep those records and be able to contribute toward a larger research project that's going on. I would say try to make it known. Let's say that you're putting in, for example, there was an agency in Florida that was doing a lot of RFBs, and we did catch wind of that, and we were able to use those, and that made up the bulk of that 50 there, Charlie. Making it known, maybe to hopefully you've got some good interactions. If you're a city, you've got good interactions with your state traffic safety department. Make it known to them that you're doing this, because maybe there's some other cities in the state that are also doing it, and maybe the safety department would be able to pull that together in an evaluation. That's been done in a number of cases. There are certain types of research studies done at the federal highway level, the NCHRP level, pooled fund studies that you can be part of to kind of contribute your data without having to do the evaluation yourself. Contribute your data that's really going to help the study overall, and then also the results from it are going to apply even more directly to your jurisdiction because you contributed data toward it. Right. So that would be some recommendations.
I think that one of the big takeaways is don't feel that you shouldn't do evaluation if you're not doing it the most robust way with empirical bays. I think that knowing the effects, knowing the history of leading up to the installation and then following on what's happening at a site with respect to crashes, keeping that data in hand. You mentioned the point earlier, Srini, about simply knowing whether crashes are increasing or decreasing at a site is hugely important for an agency to know and be able to monitor without doing some type of a simple before-after evaluation. It's impossible to know that. And then being able, like you said, Dana, to contribute to bigger efforts when they do come around to pull that information into one place, and that's where the valuable CMS can be established for agencies who don't have any of that those resources to evaluation at all. That they're really relying, I think, on those good research results to come out and guide the field and the practice. Great. We have just a minute left. I wanted to ask a question that came up numerous times. I know you always get it, Daniel. If I'm in the SEMA clearinghouse and I see that a rectangular rapid flashing beacon has a CMF of X, and then I find that a raised median island has a CMF of Y, can I take X and Y, those two treatments, and apply them at one site and understand the crash reduction based on those two factors that are independent from one another? Apply them together. What does that tell us? Can you do that with a SEMA clearinghouse?
So let's say you're going to be doing two safety treatments. You're going to be doing the flashing beacon, and you're also going to be doing some kind of crosswalk improvement or something at the same location, and you've got CMFs for both of them. What CMF are you going to use as the whole project CMF? It really depends on how related they are and how much they address the same crash type. And so if, for both of these that I just mentioned, they're both really getting at pedestrian and vehicle crashes. And so if one has a CMF of 0.8 and the other has a CMF of 0.7, you need to think about the fact that you're not going to see that both of them bring down crashes as much as they would be expected to if they were just implemented by themselves. Together, they're going to have a combined effect, but I would be conservative in thinking how much effect they're going to have together. The flip side of that would be two countermeasures that would be very independent of each other, addressing two different types of crashes. Then you could expect to see the benefit of both CMFs, I would say, in that case. And in this situation, you could multiply them together. It's a multiplicative factor. You can multiply it together to get the overall project CMF. But be very careful if you've got two treatments that are addressing the same crash type. Don't expect to see the full benefit from both of them as much as if they were just implemented by themselves.
Okay. Good to know.
Yeah, the other thing to be careful about is some of the CMS, like for the ones in the study that Dan mentioned early in the webinar, the pedestrian hybrid beacon and RFPs, the actual treatments that were evaluated as part of the study did have combinations of pedestrian hybrid beacon combined with median island, combined with advanced yield line, for example. So, when you look for a CMF, be sure to see whether it was an individual treatment or a combination.
Okay. Great. Well, that's good information and a good point, I think, to close on today. So that is all the time, unfortunately, that we have for questions and discussion. I just want to thank Daniel Carter, Raghavan Srinivasan, Krista Nordback, and Charlie Zagier all for joining us today and adding your expertise, your experience in doing this evaluation, this research to the discussion today. I think that for my own purposes, we've talked a lot about good crash-based evaluation today, and I think maybe a subsequent session we can shift and maybe focus more on some of those surrogate measures. And you talk about a range of methods, Srini, for crash-based evaluation. You look at surrogate measures, it is really wide open in terms of the different measures you can look at to evaluate the effects of a different type of treatment. I think that deserves its own maybe separate conversation, and we can look at that as we sort of head into the new year. I want to remind you all that are still on the webinar with us that we are going to be sending out an email later today in about an hour that'll have a link to your certificate of attendance for the webinar. The archive page for the session will be posting the recording probably by tomorrow. I'll have that up and running. We would appreciate your feedback to us as you close the webinar today. You'll be greeted with a survey and allow you to provide some comments back to us. We'd really appreciate your feedback and maybe your own ideas about priorities for both research and evaluation like we're talking about, but then any ideas you have on future sessions you'd like to hear. We're thinking about the next year now in the webinars that we'll be delivering. And so we're interested in your feedback on what topics you want to hear more about. Again, thank you to our panel, and thanks to all of you for attending today's PBIC webinar, and I hope you all have a great day.